This is section 161. We're going to take a look at graph of functions, and we're going to start with piecewise functions. So we're going to graph functions, and we're going to graph piecewise functions in this lesson. Now, in a previous section, we defined a function as a special type of relation. Remember, it has that one-to-one type of relationship where you only have one x-coordinate matched to only one y-coordinate. Now, in this section, we're going to examine a different type of function, and we're going to call it the piecewise function. Now, just remember our fundamental graphing principle. It says that the graph of a function f is the set of points which satisfy the equation. So the point xy is on the graph, and it's a value that makes the equation true. Now, what does this mean? It means that if we are dealt with graphs where it's like y equals, or in this case, it says f of x. Remember, f of x, another way of just saying y equals. We learned about domain, and we can think about, well, what are some domain restrictions? Do I have x inside of a square root? No. Am I dividing by x? No. So that means I can pick any x value. And when you pick that x value, you can create a chart. So these values you pick. So if you take -3, you're going to plug -3 in for x. Simplify it, and in this case, you're going to get 6. Now, if you do that for every single point, you're going to get a set of points of x and y values. You can take those and put them on the graph, right? If you take in -3, 6, -2, 0, -1, -4, right? You just plot these points, and you get to create the shape of the graph. Now, let's look at a piecewise function. Now, when we graph a piecewise function, basically it's both graphs existing simultaneously on the graph. The only difference is this domain feature to it. So we have the graph, and then we have this domain feature where we say where the graph exists. So the way that we interpret this is that for this function, this graph exists if all of your x values are less than 1. This graph exists if all of your x values are greater than or equal to 1. So let's take a look at what that means. Now, visually, what we're going to do is we're going to kind of think of how this graph is being divided up. So because this says x is less than 1, x is greater than 1, that means that this graph, the 4 minus x squared, is going to be on that side. And then on this side, the graph is going to be x minus 3. And so to graph them, all we need to do is just pick values and graph it. So for example, for 4 minus x, all I want to do is just be strategic about the values that I pick. So for example, if I know x is less than 1, I'm not going to pick 2 or 3 or 4. So it looks like if I pick values at 1, 0, -1, and -2, it's going to give me an idea of what this graph is going to look like. So 0, -1, 1, and -2. Now you just plug them in. If I plug in 0, 4 minus 0 gives me 4. If you plug in 1, 4 minus 1 gives you 3. If you plug in -1, 4 minus -1 squared, that gives you 3. If you plug in -2, 4 minus -2 squared, that's 4 minus 4, so you get 0. You can take those values and then you can plot them. Now, because this line, it doesn't say equal to, we have to represent that point as an open circle. It can't equal that value when it's at 1. So we just say open circle. But the rest, it can equal them, so we have a closed circle, and then you just connect them because it's an equation. So now we do the same thing to the other one. X minus 3. Let's be strategic about the values that we need to pick. So we can start here at 1, and then do 2, and then do 3, and then maybe 4. and we can plug those values. So 1, 2, 3, and 4. So plug them in. If you plug in 1, you get -2. If you plug in 2, you get -1. If you need to pause the video to double check that, do it. But now you get a set of points. You plot the points. So if I plug in, put a -1 or 1 on the graph, 1, -2, 2, -1, 3, 0, and 4, 1. And then now I can connect them because it's an equation. This right here is your answer. This is our piecewise function. Let's look at another one. So this says x minus 2 if it's less than or equal to 0, and x squared if x is greater than 0. So it seems like the two different graphs are going to be broken up at 0. So this side where it's less than or equal to 0, that graph is x minus 2. And on this side, that graph is going to be x squared. So we create a chart. So my chart for x minus 2, remember, be strategic about it. So maybe start picking values for x at 0, -1, -2, -3, -4. Plug those in. Plot it. Once you plot it, you can connect it. Next graph. Be strategic about the values we can pick, right? It has to be greater. So 0, 1, 2, 3. Plug those values in. Now, this one equal to, that's why it's solid circle. For this one, because it's not equal to, that means I'm going to represent that point as an open circle. Connect it because it's an equation. So what did we learn today? We talked about piecewise functions. Now describe in your own words how to graph a piecewise function. So the best way to do it is to look at the domain of your piecewise function, to be able to divide the graph into the two different graphs. You can do 3 or 4 different graphs, right? But you divide them up into the different graphs, and then you create an XY table for each graph, and then you plot them. Now, would a piecewise function have an impact on domain and range? How so? Well, with a piecewise function, you can restrict the domain of the graph however you need to, which in turn will affect the range. This does conclude our lesson. If you have any other questions, please leave them in the comments.